Okay, good morning, friends. I'm here again with the second topic of the chapter electrochemistry. We've talked about electrolytic cells, and we know that certain substances are deposited at the cathode and the anode. Now we are going to study about Faraday's first and second law of electrolysis. What is Faraday's first law of electrolysis? According to Faraday's first law of electrolysis, we know certain substances are deposited at cathode and certain substances are deposited at anode when we are talking about an electrolytic cell. So, according to Faraday's first law, the mass of the substance which is deposited at a particular electrode is directly proportional to quantity of electricity passed. मतलब जितनी इलेक्ट्रिसिटी हम पास करेंगे उतना ही अमाउंट उस पर्टिकुलर सब्सटेंस का उस पर्टिकुलर केमिकल का डिपॉजिट होगा. दिस इज Faraday's first law of electrolysis, which states that mass of a substance which is deposited at a particular electrode is directly proportional to quantity of electricity passed. If W or M be the mass of the substance, if W or M, if you can very clearly see, is mass of the substance, M or W will be directly proportional to Q. What is Q here? Q is the quantity of electricity passed. If you remove the proportionality sign, जब equal to लगा दें, तो we are introducing a constant which is called Z. Z here is called electrochemical constant. Z here is called electrochemical constant. So we can write down, now you know that Q, that is quantity of electricity, Q is equal to I into T. I is the current in amperes which is passed and T is the time in seconds. So we can write down M, हम उसको M भी ले सकते हैं, M is the mass of the substance deposited, हम उसे W भी ले सकते हैं, W is will be equal to Z into Q है, it will become Z into I into T, where Z is a constant called electrochemical equivalent. Now what is Z? Z is equal to, Z अगर मुझे निकालना हो किसी उसमें लिए, तो Z is equal to equivalent weight of that substance divided by 96500. How did 96500 come? That I'll tell you in my next concept, that is quantitative concept. Now, in order to, what is an equivalent weight of a substance? Equivalent weight of a substance, suppose I want to find out the equivalent weight of sodium. So it will be atomic mass of sodium, which is 23, divided by N. What is N? N is number of electrons gained or lost. सोडियम आयन पॉजिटिवली चार्ज है तो एन की वैल्यू क्या हो जाएगी 1. तो अगर मुझे सोडियम का इक्विवेलेंट वेट निकालना है, इफ यू रिमेंबर मैंने इससे पहले आपको इक्विवेलेंट वेट निकालना बताया व्हेन वी वर टॉकिंग अबाउट नॉर्मैलिटी, तो इट विल बी गिवन बाय 23 डिवाइडेड बाय 1. ठीक है, दैट विल बी द इक्विवेलेंट वेट, दैट इज 23 grams इज द इक्विवेलेंट वेट ऑफ सोडियम. सो आई हैव टू फाइंड आउट द इक्विवेलेंट वेट ऑफ कॉपर. तो कॉपर का एटॉमिक मास इज 63.5, तो 63.5 डिवाइडेड बाय 2. Here Z कैसे निकालेंगे? 63.5 divided by 2 into 96500 coulomb. This is equal to Z. Z will be equal to 63.5 divided by why 2? Because copper carries a charge of +2. If it is aluminium, it will become 27 divided by 3 into 96500. This is how do we find out, because we have to do numericals based on this. So what is Faraday's first law? The amount of substance which is deposited at a particular electrode is directly proportional to quantity of electricity passed. M is directly proportional to Q. Q is quantity of electricity. Q is I into T. I is current in amperes, time T in seconds. So finally your equation becomes W is equal to Z into I into T. Now Z, how do you calculate for different ions? Depending, suppose it is aluminium, how will we calculate Z? It will be 27 divided by 3. Why 3? Because aluminium carries a charge of +3 into 96500. This was your first law of electrolysis. Based on this, we'll do numericals. Now, what is Faraday's second law of electrolysis? Suppose we have got 2 to 3 different electrolytic cells. We take a cell in which silver nitrate is there, anode है, cathode है, silver nitrate is there. Another cell I am taking of copper sulfate, the electrolyte है, that is copper sulfate. Again we are taking to cathode and anode. And the third, suppose I am taking sodium chloride. You can take any of the cells. If equal amount of electricity is being passed through all the 3 different electrolytic cells, then amount of silver deposited in the first cell will be directly proportional to equivalent weight of silver. Amount of copper deposited in the second electrolytic cell will be directly proportional to equivalent weight of copper. Amount of sodium which is being deposited in the third cell will be directly proportional to equivalent weight of sodium. So what is Faraday's second law? According to this, if two or three different electrolytic cells are connected in a series so that same amount of current is being passed through them, then the mass of any electrolyte, any substance which is deposited at the respective electrolytic cell is directly proportional to equivalent weight of that metal. I hope it is clear. Now suppose we have got three cells. I just now told you we have got three cells, and one is silver nitrate dipped in silver nitrate, another I am taking copper sulfate, another I am taking sodium chloride. So we can write down for them we can write down, for this cell we can write down mass of silver deposited divided by mass of copper deposited will be equal to equivalent weight of silver divided by equivalent weight of silver. You can very clearly see, मैंने फर्स्ट और सेकेंड सेल को पहले कनेक्ट करके उनका एक फॉर्मूला लिखा है, और देन हम सेकेंड और थर्ड को, हम फर्स्ट और सेकेंड को भी, फर्स्ट और लास्ट को भी कनेक्ट कर सकते थे. अगर हम फर्स्ट और लास्ट को कनेक्ट करें तो क्या होगा? मास ऑफ सिल्वर डिपॉजिटेड डिवाइडेड बाय मास ऑफ sodium deposited is equal to equivalent weight of silver divided by equivalent weight of sodium. So what is Faraday's second law of electrolysis? According to this, the amount, if two or three different electrolytic cells are connected in a series having same amount of electricity passing through them, then mass of the substance deposited at a particular electrode is directly proportional to its equivalent weight. This was Faraday's second law of electrolysis. Now let's come to quantitative aspect of Faraday's first law of electrolysis. If we talk about quantitative aspect, we know जैसे हमारे पास sodium ion, sodium has got one electron. That means in order to deposit 1 mole of sodium, we require 1 electron. अगर हम मोल के टर्म्स में कहें तो in order to deposit 1 mole of sodium, we require 1 mole of electrons. Copper has charge +2. तो हमें क्या हमें बोलना चाहिए? We can say that in order to deposit 1 mole of copper, we require 2 electrons. Similarly for aluminium, because the charge on aluminium is +3, we can write down in order to deposit 1 mole of aluminium, we require how many electrons? We require 3 mole of electrons. Now charge carried by 1 mole of electrons कैसे निकालेंगे? 1.6 into 10 to the power minus 19 into 1 mole is 6.023. So if you want to carry out the charge carried by 1 mole of any electrons, it will be given by 1.6 into 10 to the power minus 19, जो आपको मालूम है, that is charge on an electron, into 6.023 into 10 to the power 23, which you know is Avogadro's number. If I multiply 1.6 into 10 to the power minus 19 with 1 mole, that is 6.023, the value comes out to be 96500, which is equal to 1 Faradays or this many coulombs. 1 Faraday is equal to 96500 coulombs. Let me write down this also here. We can write down 1 Faraday is equal to 96500 coulombs. तो 1 मोल सोडियम, मतलब मुझे अगर 23 ग्राम्स सोडियम को डिपॉजिट करना है तो हमें कितने कूलम्स की जरूरत पड़ेगी? 1 कूलम, 1 फैराडे, या अगर हम कूलम में बोले तो 96500 कूलम्स. सपोज आई वांट टू डिपॉजिट 63.5 ग्राम्स ऑफ कॉपर, जो कि 1 मोल के बराबर है. तो हाउ मेनी electrons do we require? We require 2 electrons. That means 2 mole of electrons. That means we have to have 2 Faradays, or we can say 2 into 96500 कूलम. सपोज मुझे एल्यूमिनियम डिपॉजिट करना है. एल्यूमिनियम का 1 मोल का मतलब 27 ग्राम्स. इफ आई वांट टू डिपॉजिट 27 ग्राम्स ऑफ एल्यूमिनियम, हाउ मच अमाउंट ऑफ करंट डू आई रिक्वायर? दैट इज 3 Faradays, because charge carried by aluminium is 3 Faradays. और अगर आंसर हमें कूलम्स में देना हो So 3 into 96500 coulombs. That is 3 into 96500 coulombs. I hope Faraday's first law and second law is absolutely clear to you. And next topic which we have to do, that we will do, that I'll carry out in my next video.